I've given a lot of talks over the years, and this is probably like the nicest ballroom that I've had the chance to speak in. So before I begin, I just want to tell you a little bit about who I am and why I'm here today to talk to you about generative AI and how it can be effectively used in the enterprise. So my name's Nate Slater. I'm one of the founding team members at Flip AI. We are a Devops LLM company that's basically training LLMs that are capable of interrogating observability data and producing a root cause. Oops, we just lost. Hold on one second here. We back? Okay. So we have a product that's actually able to use LLMs to produce root causes from observability data. So we spend a lot of time training models and working with the technology. Prior to founding Flip, I actually worked at AWS for about 10 years, and about 4.5, 5 of those years I was in the AI and ML services organization, actually leading a team of applied scientists that were building bespoke ML models for customers. So over that 4.5 and change years, probably worked on several hundred POCs. So I saw a lot of different AI use cases and a lot of different industries. Part of what I'm going to talk about today are some of the challenges that we saw with enterprise adoption of AI and ML. Okay. So generative AI is easily the most talked about topic in technology today. I guess I could even start this off like, who here hasn't heard anything about generative AI over the last 6 months, right? Zero, right? Everybody's talking about it. Clearly, there's something going on here, really powerful technology. But we've been through these hype cycles with AI before, right? And the reality is that the majority of AI proof of concepts fail to become production deployments. And today we're going to talk a little bit about whether generative AI actually changes that, right? My experience at AWS between 2018 and 2022, we worked a lot with neural networks, we worked a lot with sort of larger models, but it wasn't much generative AI. It was still sort of the previous generation of neural networks, and then even some classical machine learning. So really the question is, why do these projects fail? And is there anything we can learn to make sure that enterprises now can actually be more successful with the technology? So a couple lessons learned from my, again, 5-ish years in the AI and ML org at AWS. So there's lots of enthusiasm to do POCs, right? We had absolutely no problem maintaining a really full pipeline of customers, mostly enterprise customers, right? In order to qualify for this particular program we offered at AWS, customer had to be a certain size by revenue. And there were tons of enthusiasm to actually work with us on building POCs. But most of these POCs failed to convert to production workloads. So in other words, we deliver the POC, customer would say, hey, that looks great, but it just wouldn't make it into production. And in fact, more than 50% of these POCs failed to convert. And I can't give you the exact numbers of the goals that we took in the years that I was leading this part of the org, but I'll just say that if we had hit 50% as the rate of conversion from POC to production, we would have been over the moon, right? It would have been just ecstatically, good news. So we have all these new technologies. We have these managed LLM services. Is this going to be enough to sort of solve this problem, to increase this success rate? Right, we have OpenAI, we have Amazon Bedrock, we have Cohere, we have Google Vertex AI. There's no doubt these are really, really exciting new services. And there's no doubt that these services do solve some of the challenges that we typically would see in converting a POC to production. Obviously, the big one is the data labeling challenge, right? These generative AI models can actually learn from the text itself, so you don't have that data labeling challenge, which was one of the biggest obstacles for most customers to adopt machine learning. If you don't have labeled data and you're doing supervised machine learning, you're kind of out of luck. But there were two other challenges as well. There was the trust issue, right? So a lot of these previous generation machine learning models were very opaque. Even if we were able to deliver a successful model to a customer, the customer oftentimes had trouble interpreting the results of the model, or they weren't sure why the model was returning one result or another. And so as a result, they didn't want to use it in production, right? It was still too black box, still too opaque. We'll talk a little bit about the opacity problem and the trust problem in generative AI because it hasn't gone away, but it's a little different than what we saw before. And then finally, there's the cost issue, right? So for many customers, the cost of actually implementing a model in production was just too high, right? Something like 90% of your costs when you're running an ML or an AI model are going to be an inference. And in order to make your workload benefit from the AI, if you have to do so many inferences that it's just going to balloon your cost of running the model, that can be a deal breaker, right? Now, the cost issue is interesting with these managed LLM services because they certainly do have an economy of scale, right? And the reason they get that economy of scale is because the actual compute that's returning the responses is multi-tenant, right? So just want to be clear, even in something like Amazon Bedrock, where maybe you get a virtual private cloud endpoint into the service itself, when the service goes to actually compute your response, to generate the tokens for your response, that's happening on shared infrastructure. So you kind of have solved the cost problem with these cloud services, but there's a footnote to it, right? Because for many enterprises, that sort of last leg of isolation is a deal breaker, right? They really don't want their data, on a GPU that's next to like their competitors' data. And I know Amazon and all the big cloud providers do a really good job at segmenting and isolating data, but again, in the enterprise space, that can be a deal breaker. So for the rest of the presentation, we're really going to focus on those two obstacles, the cost obstacle and the trust obstacle, and what we need to do to overcome those in the age of LLMs. Just some numbers to kind of drive this point home, right? You'll see that 33% growth. This is from a survey that Morgan Stanley did of CIOs in 2023. So something like 33% of CIOs are saying, I plan to have some kind of production generative AI / LLM workload in place by the second half of 2024. And that's great. That looks like a pretty significant acceleration. That's one of the tallest bars on this chart. That's wonderful news. But remember, the POCs that are going to determine which of those workloads make it into production are either going on right now or they're in planning, right? And so if you have a 50+% failure rate on conversion from POC to production workload, by the time we get to June of 2024, we all may be very disappointed if these are not converting at a higher rate, right? So the estimates may actually be more optimistic than the actuals. So the question is, what can we do now? What can we do if you're a founder, an entrepreneur, somebody who's building with large language models, or even an enterprise that's looking to adopt these models? What are some of the things that we can do now to hopefully improve the rate of conversion from POC to production? And what are some of the observations we can make from the enterprise customers that we're working with? And that's what we'll explore in this session, right? We're going to explore what we at Flip AI are hearing from our enterprise customers about LLMs. We're going to talk about some of the challenges of using enterprise data with these managed cloud-based LLMs. And then we're going to talk a little bit about how we're actually overcoming some of these challenges in the way that we're actually approaching building these LLMs at Flip. Okay, so we've all seen these numbers. If you're in the same circles that I am on LinkedIn and Twitter or X or whatever it's called now, this is a slide that's been going around. Basically, I've probably seen it, randomly appear in my inbox or in my feed at least a dozen times in this last week. This is actually taken from Sam Altman's keynote at the OpenAI Dev Days last week. And the numbers are nothing short of impressive, right? 2 million active developers, 92% of Fortune 500 companies, 100 million weekly active users. I spent a lot of time at AWS in meetings about the growth of certain AI services there, and I can tell you any product manager, general manager would be salivating over these numbers, right? If you're a cloud services company, this is really, truly impressive. But the numbers don't tell you everything, right? The 92% of Fortune 500, for example, it doesn't tell us whether or not those customers are really considering these technologies for actual production work, or if they're really still in exploratory mode, right? Maybe they're allowing their developers to open accounts that give you sort of an API key, and you can, prototype stuff, but, it's still not likely that a lot of those types of efforts are going to actually wind up as production use cases. So what are some of the observations that we can, kind of call out to see if there's ways to overcome some of the challenges in this adoption? And some of the things that we hear at Flip when we talk to enterprise customers, and even though we're a seed stage startup, it's kind of ironically, most of our customers actually happen to be enterprises, which is a little bit unusual, especially compared to sort of the 2010s kind of startup trajectory, which is a lot of sort of product-led growth. Things have sort of changed now. And so we've talked to dozens and dozens of enterprises, and we have a dozen or so that we're actually in active POC mode with. And there's sort of three main requirements that we've been able to distill from these, dozens and dozens of conversations that we had with these enterprise customers. And the first is the models have to understand the customer's business data. You can walk into a customer meeting with a really slick demo that uses some kind of public data set or maybe even some kind of sanitized or even synthetic data set that you've created to really show the power of these large language models. And the first question you're going to get is, wow, that's really cool, but I need this to work on my data, and my data is really idiosyncratic because we've got, decades of business processes that we invented here, and those business processes are what create this data or inform this data, right? So you have to be able to demonstrate that the LLM solution is going to be able to derive legitimate insights from the customer's business data. Second point on this list should not be of any surprise to anybody that's worked in machine learning over the last several years, but it's really a binary requirement, right? There's only one right answer to the question when you get into a meeting with an enterprise customer, and they ask, do you use our data to train models that you'll make available to other customers? The answer is no, you cannot do that. You have to meet this requirement. And in fairness, all of the large cloud-based LLMs, as well as the hyperscalers that offer LLM solutions like AWS, GCP, and Azure, they're going to have data processing agreements that make these guarantees. Okay, so that one, that's kind of a not so interesting point, but really, you have to be clear that you're never going to use the customer's data to train a model that you make available to somebody else. And then finally, these solutions need to be cost effective and they need to have measurable return on investment, right? If it doesn't, in the world that I'm in, which is sort of dev tools and observability, it just becomes yet another, $30, $40, $50 a month subscription that you're buying for your developers without any real understanding of how much leverage you're getting from that investment. Okay. So let's go back to the trust situation, right? Remember how I said in 2018, 2019, 2020, one of the biggest issues, even if you were able to deliver a successful POC to a customer, was how do I trust the results, right? And back in those days, a lot of times the output from the model was actually something that was difficult for humans to understand. It would be a top 10 highest probability output, and you sort of have to decide, well, what's the probability threshold that I'm gonna basically assume anything above that threshold is an accurate response. Human brains are not wired to think probabilistically, so that's just a hard one for people to get over. Generative AI, on the other hand, gives you a response that's much more accessible to the human brain, right? It's text, right? You can read it. Hey, that sounds pretty good. This looks pretty good. But you still need to know whether or not, the response is grounded in any kind of actual facts. And if you're an enterprise, the facts are basically the data that you have that you believe to be true and to sort of be your ground truth, right? So if you have this model that's been trained on a huge corpus of data and it's never seen any of your enterprise data, how do you make sure that the model generates a response that's factual? Well, you do it with something called retrieval augmented generation, right? So retrieval augmented generation is you sort of give the model a document or some facts when you ask the model to generate a response, and that sort of nudges the model in the direction of kind of grounding its response in something that you know to be true. And this works really well. And in fact, most of the best practices and reference architectures you're going to see today around building an LLM solution probably do something along these lines, right? And in fact, some of the other things you might have noticed, all this talk about vector databases and these sort of new data, bespoke data storage systems that are basically, being widely used when developing with LLMs, that's directly related to this, right? The vector databases give you a way of sort of retrieving those facts that are semantically similar to the prompt that you're sending to the model. So it works really well, but you have a little bit of what I call the RAG paradox here, okay? So you need to first build this knowledge base that has what you consider to be those ground truth facts in it. You may have all kinds of data in your corporate environment, Google Drives with all sorts of documents, CRM systems with case management, whatever it is. And you may largely trust that data. You probably think, yeah, it's reasonable, it's reasonably truthful. But using it in its sort of rawest form isn't going to be great, right? There's going to be some data curation and some data classification, maybe some data enrichment you're going to need to do. So building that knowledge base is kind of a precursor. You think, okay, great. The LLM should do this for me, right? I can feed it a whole bunch of documents. I can ask it to summarize those documents for me. I can ask it to classify maybe the topics that it sees in those documents. I can capture all of that into some kind of index, like a, say, OpenSearch or Elasticsearch index, and I can build this, really great tool for querying, data, or querying the documents that have the data that I need from them. But you see the problem, right? If you use the LLM to build that source of ground truth, how do you know the LLM is actually correctly giving you responses that you can trust, right? You don't have those facts that you can give it. So that's a little bit of the chicken or an egg problem here. And so you quickly hit the wall with retrieval augmented generation in some cases, not in all cases, but certainly in some. Okay, so how about training your own model, right? If it's going to be all this work to build this knowledge base just to do retrieval augmented generation, why don't we just train our own models, right? Hey, you're a big enterprise, you've got big IT budgets, you may even have a data science team. You can partner with somebody like OpenAI. This actually also was from Sam Altman's recent keynote. And you'll notice though, it's very expensive, $2 to $3 million in several months of time just to train a custom model that is going to be out of reach for even the largest enterprises. And keep in mind too that this is not a one-time cost. This is actually an ongoing cost because models are trained on a certain corpus of data, certain knowledge, and that knowledge gets stale over time. And in fact, Sam Altman even said when he was giving his keynote that one of the biggest complaints that they were getting from their 2 million developers using their APIs was that Turbo 3.5, which is the model that until recently was powering ChatGPT, had a cutoff date of 2021. That means it hadn't seen any data past 2021. So that's a big problem, right? Especially if you're querying for technical information. In fact, ChatGPT couldn't even really tell you things about ChatGPT because it was trained on data before ChatGPT existed, right? So you're going to have to keep training these models over and over again, and this is just a huge cost. And most customers aren't going to do this. Okay, so where does that leave us, right? So we had to solve for these problems, right, for our enterprise customers. And so we took a three-pronged approach. The first thing that we did was we decided we were going to start with open source foundational models. There's a lot of really good ones out there, particularly some of the stuff coming out of Facebook. We've had very good luck with Llama and some of those. But we intentionally started with models that were not of the massive size, right? We don't need hundreds of billions of parameters for what we're trying to do. We only need, say, tens of billions. And what that means is the models are smaller, right? We don't have to show them nearly the same amount of data that we would to train one of these, big multi-purpose models. We also spend a lot of time, and probably the most significant investment we make when we go to train a model is on that second item on the list, which is we pre-train, instruction tune, and fine tune with highly curated data sets that we produce, that we acquire and produce. And these are drawn directly from the target domain that we're working in. So this is largely observability data, things like log files, events, Metrics, not so much, because LLMs aren't very good at math. But we'll augment that with, issues like from GitHub projects and technical documentation, API documentation, right? All of the things that developers are likely to look at when they're debugging a problem. And we spend a lot of time on the data curation piece. I've actually recently had to write some of the code that runs in our pipeline to prep this data, and it's an area where we actually focus on getting everything right. So that by the time you actually go to train the model, which is going to cost you a lot of money and a lot of GPUs, you can feel confident that your model is going to work. Generative AI conforms to the same axiom as any other machine learning technology, which is garbage in, garbage out. If you train a model with really sort of ugly looking data, it'll generate something for you, but that something is not going to be very useful. And then the third one may be a little less sort of intuitive, but what we do is we build the integrations that have the data that our model is going to actually interrogate. We build direct integrations into those systems, right? So in our case, these are observability platforms. We don't pull the data out. We don't index it. We don't, run embeddings on it and store it in vector databases, right? We want to keep the source data as close as possible to the LLM. And I'll explain a little bit more about that as we go through this. Okay, so one of the things that we realized we could do to really come up with these really sort of good data sets for training the types of models that we need to train is that we realized that chaos engineering can actually work well for us. So because we're training our model to identify the root causes of various system and application faults, we can actually run all of these different sample applications that use all kinds of different architectures, everything from sort of monolithic kind of J2EE type architectures that were really common back in the early 2000s to the sort of more modern microservices architectures that do everything asynchronously with Kafka message queues and so on and so forth. So we run all these apps that have a sort of lot of variation in the technological or the architectural components. And then we inject fault scenarios into those, right? We have a pretty good understanding of what sort of the universe of failures are within these different architectural components. And so we can create these chaos scenarios and inject those into these applications while capturing all the metrics, events, logs, and trace data and in these different platforms, right? So we get a really nice cross-section of data, and then we can use that to train our models. So obviously this won't work in every situation, but this is an example, I think, of the kind of creative thinking that you need to be willing to do to really get those data sets that are going to give you high accuracy models. And in our case, what we're really shooting for is that zero-shot accuracy, meaning can we bring a model into an enterprise customer and show it some of their observability data that the model has never seen before and actually have it give meaningful insights from that data. Okay, so a couple of other things, right? Again, going back to that, 93% or 92% of Fortune 500 customers are using OpenAI. I have no reason to doubt that Sam Altman isn't being completely truthful in his numbers, but at the end of the day, again, what does that really mean, right? Like, if you build a compelling solution, but the customer, the enterprise customer says, you know what, my security operations team really does not allow any multi-tenant type cloud service in our environment, you sort of have to play by the enterprise customer's rules, right? If you're going to try to change the rules so that they do something new, it's going to take what's already a long and frankly rather painful procurement process and just make it any longer. So what we've done is we've decided, how can we remove friction from this process, right? How can we basically get our technology into the enterprise in a way that conforms to best practices and sort of security posturing that they've already agreed to sort of work with. And in our case, the answer is single tenant deployments in the customer's own environment. And we can do that because we don't require massive arrays of GPUs to run the models, right? We can fit our models on 2 GPU instances, which is well within the sort of reasonable amount of sort of compute costs that customers are already used to. You know, if you want to end a pre-sales meeting really quickly with a customer about your LLM solution, tell them that they've got to spend, you know, $80,000 a month on NVIDIA GPUs just to run your solution, right? That meeting will end right away. And by the way, it's not likely that they have that capacity just sitting around somewhere in their data center. And you know, we've talked to some of the biggest, most tech-savvy sort of Fortune 500 companies out there, and they don't have them, right? Nobody can get GPUs right now, so smaller models work well for us. And then the other thing you'll notice in this is just those direct integrations to the data systems, right? So we don't, if anything, I would say, draw your attention to what's not on this diagram, right? No sort of streaming data buses that require, different big data technology, data engineering to sort of extract the data, transform it, index it, right? We can basically query directly from the observability systems. And it makes sense, right? These observability platforms are really, at the end of the day, big data platforms. They have really nice query capabilities. They index data already. They provide metadata about the data. We just use that, right? So we try to keep the integrations as simple as possible. And in fact, if you're using some of the cloud-based services like Elastic Cloud or Datadog, you know, we can integrate within minutes, right? All we really need is just an API key and an endpoint and read-only access into those systems. So this has been, I think, a big sort of learning for us, which is, you have to play by the enterprise's rules. And no matter how cool a technology is, that's not enough on its own to get the enterprise to change their rules just for you. Okay, so let's go back to the truthfulness of the models, right? How do you convince your customers that your models are producing meaningful, truthful outputs? Well, in our case, whenever we generate what we call an RCA candidate, and if you read that text down at the bottom, that's actually all generated by our language model, but we always show corroborating metrics to basically as evidence that the hypothesis the model has produced is accurate, right? So, on the right-hand side, you'll see we call that supporting metrics. And so if the model hypothesizes, as it is in this case, that the issue is due to an unindexed database query, what we will do is we will then ask the model, okay, given an unindexed query, and given that we have all these database metrics over here, which are the metrics that appear to be corroborating this hypothesis? And you can see our models are even able to do some time series analysis and find peaks and other things that look like they corroborate the hypothesis of an unindexed query. And then I know it's a little hard to see, but under the Flip AI logo there, you'll actually see the AWS logo. So we always surface the source of where the data comes from. So in addition to the metrics themselves, we always tell the customer, oh, and these are coming from your AWS CloudWatch metrics or whatever they happen to be. Could be Datadog, could be Splunk, could be whatever. And this is really, really popular with our customers, because if you think about what we're actually doing here, it's really emulating the way humans think about a problem, right? If you're debugging an issue, you're going to come up with a hypothesis. Hey, I think this is due to an unindexed query, and then you're going to look for other data that supports your hypothesis. And that's really how we've leveraged these language models to really sort of mimic what the human does. But of course, we can surface large amounts of data without having a human to need to click through dashboards and run queries by hand, right? The models do all of that for us. So let's return to the original question we posed at the beginning of this talk. What problems should enterprises actually trust an LLM to solve, right? So first and foremost, pick a problem that's rooted in specific domain data. And the reason you want to do that is these are going to result in higher value solutions, right? Because they're going to involve specialized, differentiated business processes, right? If you're picking a problem that's rooted in sort of very general data, and there are business processes that meet that criteria, you can think of things like maybe some standard sort of human resources processes, maybe some payroll type processes. Yeah, sure. I mean, a big, trillion parameter model has probably seen enough examples of that data to be able to give you, meaningful results, especially if you use retrieval augmented generation. But you're not going to really get a lot of competitive leverage out of that because all your competitors are going to very easily be able to automate those processes as well. So, focus on the things that really allow you to get sort of high ROI of your your crown jewels, which is your business data. Focus on problems where the domain data can be consumed directly by the LLM. Probably the second fastest way to end a pre-sales meeting about your LLM solution would be to tell the customer they got to install a whole bunch of new big data platforms and bespoke databases just to make use of your LLM, right? They don't want to do that. So if you can avoid having to do indexing and data enrichment and classification and vectorization and all that stuff, you know, it really will increase the probability of success. And then finally, you know, the third point, this probably seems just glaringly obvious to everybody in the room, but you know, whenever you have a hyped up technology, it's kind of easy sometimes to get lost in just the coolness of the technology. It's very easy as a developer today to build a kind of cool, gadgety app on top of an LLM. But if that's not solving real pain, that's never going to really make it into the enterprise. It's certainly fun to build those things on the weekends and on the evenings if you want to play around. But just, yeah, avoid the temptation to think that just because you can sort of reimagine something that people can do today by using an LLM, that's going to be an actual product. It probably won't be, right? You really want to focus on things that are actually painful. And that's all I have. So thanks a lot. Appreciate the chance to speak. And visit us at our website, and we'd love to hear from you.